Emergency lighting systems are crucial for safety, especially in hallways and stairwells, particularly when normal power is interrupted. According to the National Electrical Code, or NEC, emergency lighting must be supplied from a source independent of the regular power source to ensure illumination during power outages. This typically involves a battery backup system or a generator that can automatically switch on when the main power fails. The specific requirements for emergency lighting circuits are outlined in the NEC, and it's essential to adhere to these regulations to maintain safety and code compliance. Emergency lighting should be on its own dedicated circuit. This means that the emergency light should not be connected to the same branch circuit as general lighting or other electrical loads. The reasoning behind this requirement is to ensure the reliability and functionality of the emergency lighting system during an emergency situation. If emergency lights were connected to a shared circuit, a fault or overload on the general lighting circuit could potentially disable the emergency lights, defeating their purpose. A dedicated circuit provides a reliable and independent power source, ensuring that the emergency lights will function as intended when needed most. From a technical perspective, the NEC mandates specific wiring and overcurrent protection requirements for emergency lighting circuits. This includes using appropriately sized conductors, installing dedicated circuit breakers or fuses, and providing proper grounding. The overcurrent protection devices must be selectively coordinated to prevent nuisance tripping and ensure that only the affected portion of the circuit is de-energized in the event of a fault. Furthermore, the NEC addresses the placement and type of emergency lighting fixtures. Emergency lights must be positioned to provide adequate illumination along the path of egress, including hallways, stairwells, and exit routes. The lighting fixtures must be designed to provide sufficient light output and have a specified duration of operation during a power outage, typically a minimum of 90 minutes. Regular testing and maintenance of emergency lighting systems are also crucial to ensure their proper functioning. The NEC requires periodic testing of the battery backup systems and lighting fixtures to verify their operational readiness. Any deficiencies or malfunctions must be promptly addressed to maintain the integrity of the emergency lighting system. To elaborate further, consider the practical implications of sharing a circuit between emergency lighting and general lighting. Firstly, the potential for overloading the circuit is significantly increased. General lighting loads can fluctuate depending on the time of day and occupancy levels, which can place additional strain on the circuit and increase the risk of a break or trip. If the emergency lights are connected to the same circuit, they may be inadvertently de-energized due to an overload caused by the general lighting. Secondly, any maintenance or repairs on the general lighting circuit could disrupt the power supply to the emergency lights. During routine maintenance, the circuit breaker for the general lighting may be switched off, which would also cut off power to the emergency lights. This could create a hazardous situation, especially if the building is occupied during the maintenance period. Thirdly, the integrity of the emergency lighting system is compromised. If a fault occurs in the general lighting circuit, it could potentially damage the emergency lighting components. For example, a short circuit in a general lighting fixture could cause a voltage surge that damages the battery backup system or the emergency lighting controller. From an engineering standpoint, the design of emergency lighting circuits involves several considerations. The load calculations must be performed accurately to determine the appropriate size of the conductors and overcurrent protection devices. The voltage drop must be kept within acceptable limits to ensure that the emergency lights receive adequate voltage during a power outage. The wiring methods must comply with the NEC requirements for emergency systems, which may include using fire-rated cables and raceways. In addition to the NEC requirements, local building codes and regulations may also impose specific requirements for emergency lighting. It's essential to consult with the local authorities to ensure compliance with all applicable codes. The inspection process for emergency lighting systems typically involves verifying that the circuits are properly wired, the overcurrent protection devices are correctly sized, and the lighting fixtures are installed according to the NEC requirements. The inspector will also test the operation of the battery backup system and the lighting fixtures to ensure that they function as intended. Failure to comply with the emergency lighting requirements can result in fines, penalties, and potential liability in the event of an accident or injury. It's crucial for building owners, facility managers, and electrical contractors to understand and adhere to the NEC regulations for emergency lighting to ensure the safety of occupants and maintain code compliance. To provide a more detailed understanding of the NEC requirements, let's examine some specific sections of the code that address emergency lighting circuits. The NEC Article 700 covers emergency systems, including emergency lighting. This article outlines the requirements for the source of power, the wiring methods, the overcurrent protection, and the testing and maintenance of emergency systems. NEC Section 700.12 specifies the permissible sources of power for emergency systems. These sources may include storage batteries, generators, uninterruptible power supplies, or separate service feeds. The selection of the appropriate power source depends on the size and complexity of the emergency system, as well as the specific requirements of the application. NEC Section 700.9 addresses the wiring methods for emergency circuits. The code requires that emergency circuits be installed in a manner that minimizes the risk of damage or failure during a fire or other emergency conditions. This may involve using fire-rated cables, installing the circuits in rigid metal conduit, or providing physical protection against mechanical damage. NEC Section 700.27 outlines the requirements for overcurrent protection of emergency circuits. The code requires that emergency circuits be protected by overcurrent devices that are selectively coordinated to prevent nuisance tripping. This means that the overcurrent devices closest to the fault should trip first, minimizing the extent of the power outage. NEC Section 700.4 addresses the testing and maintenance of emergency systems. The code requires that emergency systems be tested periodically to verify their operational readiness. The testing must be conducted in accordance with the manufacturer's instructions and the applicable codes and standards. Any deficiencies or malfunctions must be promptly addressed to maintain the integrity of the emergency system. In summary, emergency lighting circuits must be on their own dedicated circuits to ensure their reliability and functionality during an emergency situation. The NEC provides specific requirements for the wiring, overcurrent protection, and testing of emergency circuits. Compliance with these requirements is essential for maintaining safety, code compliance, and the integrity of the emergency lighting system. It is crucial to consult the specific requirements of the local codes. Consider this example to highlight the importance of dedicated emergency lighting circuits. Imagine a commercial building with a large open office area. The general lighting in the office is powered by several branch circuits, each serving a number of lighting fixtures. The emergency lighting system consists of battery-powered emergency lights strategically placed throughout the office area to provide illumination during a power outage. If the emergency lights were connected to the same branch circuits as the general lighting, a fault in one of the general lighting fixtures could cause the entire circuit to trip, including the emergency lights. This would leave the office area in complete darkness, creating a dangerous situation for the occupants. However, if the emergency lights are on their own dedicated circuit, a fault in the general lighting circuit would not affect the emergency lights. The emergency lights would continue to function, providing illumination and guiding occupants safely out of the building. This example demonstrates the critical role that dedicated emergency lighting circuits play in ensuring the safety of occupants during an emergency. By isolating the emergency lights from the general lighting system, the risk of a single point of failure is minimized and the reliability of the emergency lighting system is maximized. In addition to the technical requirements outlined in the NEC, it's also important to consider the human factors involved in emergency lighting design. The placement and type of emergency lighting fixtures should be carefully chosen to provide adequate illumination and minimize glare. The lighting should be uniform and consistent to avoid creating shadows or dark spots that could disorient occupants. The emergency light should also be easily visible and distinguishable from the general lighting to avoid confusion during an emergency. Furthermore, The design of the emergency lighting system should take into account the needs of individuals with disabilities. The lighting should be sufficient to allow individuals with visual impairments to navigate safely, and the placement of the lighting fixtures should not obstruct accessibility for individuals using wheelchairs or other mobility devices. The design should also address auditory needs of people as well. The NEC serves as a foundational guide for electrical safety. It's important to also consider other relevant standards and guidelines that may apply to emergency lighting systems. These standards may include those published by organizations such as the Illuminating Engineering Society, or WISE, and the National Fire Protection Association, or NFPA. The IES provides recommendations for illumination levels and lighting design practices, while the NFPA publishes codes and standards related to fire protection and life safety. Consulting these additional resources can help ensure that the emergency lighting system is designed and installed to meet the highest standards of safety and performance. Finally, it's worth noting that the field of emergency lighting technology is constantly evolving. New lighting technologies, such as LED lighting, are becoming increasingly popular due to their energy efficiency, long lifespan, and improved performance. These new technologies offer opportunities to enhance the effectiveness and reliability of emergency lighting systems. It's important to stay abreast of the latest advancements in emergency lighting technology to ensure that the systems are designed and installed using the best available technologies and practices. By considering the NEC requirements, human factors, relevant standards, and technological advancements, one can design and implement emergency lighting systems that provide the highest level of safety and reliability for building occupants. The use of dedicated circuits for emergency lighting is a critical aspect of this comprehensive approach. The topic of emergency lighting and its compliance with electrical codes is a vital aspect of building safety. It involves not only the technical aspects of wiring and electrical systems, but also a deep understanding of the regulations and standards set forth by organizations like the NEC and local building authorities.